Okay, I think we're on.
Okay. Yes, we are on.
Okay, great.
Now.
Great. So I think then I will get started.
Yeah, thanks a lot for your cooperation and sorry for this little bit.
Yeah, sorry also to attendees, some technical difficulties here, but I think we have solved them now. Right. So let's begin. I will share my screen and then we can proceed.
Yeah, you can check your screen. Then I can start.
Say again?
I said that if you want, you can check share screen.
Yeah.
And then I can start to introduce you, and you can continue with your webinar.
Okay. Done.
Then start the webinar. Hello everyone, and welcome to our session, IEEE Connecting Expert webinar entitled with Towards Intelligent Immersive Virtual Environments from Dr. Alexei Tevzhakov from Estonia, Taltech, Estonia. He is Estonia YP chair, and he's a great IEEE volunteer. And by the way, he is also IEEE senior member. And today he will give us a great webinar, as I see the topics of intelligent immersive virtual environments. And he can introduce himself more, and he can give some more information about him. And Alexei, welcome to our session, and it is our pleasure to host you as a speaker in our Connecting Expert webinar series. And it is really our pleasure to make this session co-organized with IEEE Estonia YP. Welcome to our session.
Okay. Thank you very much for the introduction, Omer. So hello, everyone. Welcome again to this session. And my name is Alexei, as Omer just said. And the intent today is to present to you a talk which was actually first given at EuroVR conference in 2019, but it has been also adopted and extended beyond that material. So let's get started. Also, sorry for some technical difficulties. Sometimes this happens, but everything should be fine now. And everyone joining us live from YouTube and Facebook, welcome. Okay, so a few words about myself. So I've recently been promoted senior researcher. Facebook, welcome. Say again. Was there some comment?
Yeah, everything's okay.
Okay, so I'm senior researcher at the Center for Intelligent Systems, Department of Computer Systems, Taltech University. And I'm also head of XR lab of CIS and also VR first lab coordinator. I'm a senior member with IEEE and hold different positions within the organization, specifically with IEEE Estonia section. And you can reach me with the email provided here. So what are we going to talk about today? Well, first of all, a bit of a background. Then I also give some information about digital twins framework and extended reality. Then we briefly reflect on mathematical modeling as well, not going into deep technical details, but we need to know the nature of what we are discussing. And then something that naturally follows in the logic of intelligent immersive environments, which is an approach that I discovered in 2019 by Professor Hoffman and his colleagues, which is called the Conscious Agents Framework. And then we will conclude. Also, in the presentation, I will show some of the developments in this specific area, which have been going on here in Teltech University, and specifically in our lab. So before that, a little bit about the origins of the lab so that you know better what to expect from this talk in terms of the topic. So our origin is with control systems and control system design. And the first lab that I've been officially part of is Alpha Control Systems Research Lab. And the keyword cloud, you can see here on this slide. So you can see, for instance, intelligent control is somewhere in the middle. This is still the case for a lot of things that we're doing. Also, the thing that I've been doing during my PhD studies, which is fractional calculus, is also here towards the bottom on the right. But in general, all of this kind of these various skills, knowledge, and so forth, they somehow make possible now to create this idea of an intelligent immersive environments in the context of these issues related to automatic control and system modeling. Right, so the vision of the lab is provided here. I will probably not go into detail, will not reread the text, but the general idea is that we're working with cyber-physical systems, and through digital twins approach and through these various immersive experiences that are made possible due to the fact that we're now using virtual and augmented reality in daily lives. We try to combine this all together into a coherent whole and to provide some novel methodologies and novel applications related to control system design, human-machine interfaces, and system modeling. So also briefly mentioned that in Teltech we have another lab that is the activities of which is closely related to ours, which is IVER lab, and so it's kind of acknowledgement, early acknowledgement in these slides here. Right, so let's turn now to intelligent immersive virtual environments. After all, this is the main theme of the talk. So we have recently seen how it is possible with at least virtual reality to what kind of possibilities, what kind of opportunities lie in the domain of virtual reality, right? So in the beginning in 2014, when it was just starting out, like looking for mass adoption, quite only a few people tried it, but those who did actually understood the potential. And I was one of those people. I tried it, and I immediately knew that this is going to be the future of technology, what concerns interaction and learning and education, all those things. And since I'm affiliated with a university, obviously, immediately I started reflecting on what we're doing that can be enhanced with virtual reality and later also augmented reality. So from this, after several years of doing studies, publishing various papers on the subject, we have actually concluded that, let's say, the defining qualities of intelligent immersive virtual environments should be, of course, that they're immersive. The artificial environment must be immersive, where the user is transported, and free interaction with the components and subjects of the VE must be also made possible. But what defines the intelligence of a virtual environment? So the idea will become hopefully more clear by the end of this talk, because I will involve the conscious agents framework as part of what we will discuss. But the idea, of course, is, well, it's rather simple to understand, but to kind of understand the inner workings of how virtual environment might come about, it's a bit of a different and more complex subject. But intelligence just means that the environment somehow reacts to the user, supports the user, and makes it possible to create meaningful interactions with the user, and also maybe if there are several users, it makes it more easy to communicate between them and so forth, right? So from the technical perspective, what is an intelligent immersive virtual environment? So we have two levels of modeling. We have high-level modeling, and here we are discussing digital twins, interactions, and consciousness as well, since this forms basically this is the cornerstone of this intelligence, consciousness, the mutual understanding of the environment and the user, let's say. Right, so this is a kind of abstract modeling paradigm. Then we go to the low-level modeling, and here we have mathematical modeling, visualization, real-time performance communication, and so forth. So, and obviously machine learning, which is an attempt to replicate machine intelligence or this consciousness even in order to be able to create an intelligent, immersive virtual environment. So let's quickly take a look at the state of XR, by which I mean VR and AR technologies. So these factors actually come from 2019, but basically we can see that some of these predictions were actually quite true. So for example, here you see the Gartner hype cycle from 2017. And if we zoom in a little bit, you can see that augmented reality and virtual reality, according to Gartner's hype cycle, we're both heading towards the so-called plateau of productivity, which is the stage in development, which you can see here. So this was 2017. So imagine now, after some years, in fact, both of these technologies seem to have approached this plateau of productivity, and now we're already using them in many meaningful ways. And there's definitely also return on investment if, let's say, businesses are concerned with this one. For 2019, both of those technologies actually disappeared from the Gartner hype cycle. However, we now see immersive workspaces emerging. And come to think of it, like in 2019, if we knew what was coming, probably the immersive workspaces would have already reached, let's say, at least the through of disillusionment of slope of enlightenment by that time. However, they are doing so now. So we are still on the path there. Right. So a few encouraging numbers from the market. So looks really nice. This was 2019 once again. Some references. I will not stick too long on the slide. You can stop the recording and view it. But the question after 2019, could these predictions actually hold any merit? And well, probably you've recently heard that Facebook has decided to transform into Meta company. So taking all their services and whatnot, and Facebook at its net worth of $500 billion US, probably has the capacity to make this future happen. And so making also all of these predictions quite accurate. Okay, let's move on. The first component that I would like to discuss is digital twins. Now this component, again, there is some intuition about digital twins. So we have, let's say, the real object, and we have the digital representation of that object. But what does this digital representation actually mean, right? So let's quickly have a look at one possibility. So a lot of this discussion actually comes from the state-of-the-art paper published in 2019 in Transactions on Industrial Informatics. So as the information provided in that paper, there are several definitions of digital twins provided there. So, and like still, it all revolves around the idea that a digital twin is somehow representative of the real object in the real world. However, there are different layers, let's say, that are considered for digital twins in these different definitions. So a lot of times I hear that some people refer to a digital twin as a kind of mathematical model, whereas other people consider it more like a visualization, which is connected to a real life plant. And so they exchange information and they can update. The digital twin can actually update according to the real object. This is also another possibility. But I think the best way, the best approach to digital twins is actually think about it as both as mathematical model and as the visualization and such that you can interact with, right? Okay. So, emergence of digital twins. As you can see from the research perspective, specifically, there has been a growing interest in digital twin research. And let's have a look at how you can represent a kind of model of a digital twin in a coherent way. So here on the slide, you can see that we have the physical entity on the left. Then we also have the virtual entity on the right. We have all of these connections between those entities. And we also have two additional things, which is the database, this guy over here, and the services, which is this one. So this is a kind of five model, let's say five tuple, which represents a digital twin, because in any case, you need a physical entity, you need a virtual entity, you need services, database, and a connection between all of those things in order for a true model of a digital twin to actually arise. So some key components of digital twins are presented here, like for instance, modeling and simulation, data fusion, interaction, collaboration, service. Okay, so this is the fullest description, let's say, of a digital twin, and this makes it possible to think about them in also extended reality. So classically, we think about digital twins as just kind of models. Okay, we can interact them with using a flat screen, for example, but then there is also there's also the immersive environment, which is made possible with XR and specifically VR. So let's have a look at how the digital twin concept has been utilized there in that context. So these are some of the successful applications of XR and like space simulation, perhaps not something that will quickly give you return on investment. However, the others have already proven to be quite successful in that regard as well. So just some examples, like worksite training, for instance. So we have different kinds of scenarios that can happen on a worksite. And this specific example showcases that, okay, instead of actually using, let's say, some physical entities and interacting with them in a worksite or shop floor, you can use virtual reality to recreate a lot of these situations and to actually train your employees. So it's a kind of training scenario. Then design, obviously in automotive, this became a big thing also with, let's say, maintenance problems for, let's say, it's also a great use case. Specifically here we have VR, AR maybe is a little more intuitive, like for instance, if you go to a hangar and there's a plane sitting there and you are wearing augmented reality glasses, you can see all of the information that pertains to the maintenance task. But in terms of design, this is also quite important because this immersion, the fact that the person actually, let's say, feels that the objects are actually in front of him, provides a much better overall, let's say, working environment, because one of the things that you can achieve more easily in that case would be flow, which means that you're most productive when you have this flow, when everything just works and you can continue doing this for a long time. So this can be more easily achieved in virtual reality. So for design, this also works really well. Right, so an example of, let's say, some industrial visualization where we have some chemical production, also a use case for VR that has seen a lot of actual applications. And apart from that, this, I guess it's easy to think about this more as a kind of digital twin of the original plant. And the idea is that you can either have them connected together so that the digital twin would only be a representation of the actual processes, or you can take the mathematical model and plug it in here as well. And so this will be a kind of full-blown simulation. And of course, big thing for virtual reality and immersive environments is robotics. This example comes from our colleagues from Caltech University, and specifically pertains to safety in robotics, which means that like if a robot somehow harms a human in real life, that's it, right? So that's something that's done. But you can simulate a lot of these situations in virtual reality with a complete, with absolute safety guaranteed, because, well, not absolute, of course, due to the fact that in virtual reality you can still hurt yourself due to various other reasons. But the point is that in this case, you can interact with virtual robots, and if they somehow approach you unsafely, they're just virtual. They don't really exist. So this is another thing that you can do with this one. A bit more ambitious space simulation, and a more, let's say, relevant example, a more down-to-earth, literally down-to-earth example would be simulating the movement of Earth's cores. This is really important application, and I know from experience that researchers are actively developing this idea. Our colleagues from LRZ in Germany are working on such things that it's complicated because it has to do with big data, and with these processes, it's very difficult to model. So an immersive visualization actually helps to understand better what is going on with the dynamics with Earth's dynamics and what is happening there. Okay, however, digital twins still can not really be imagined without proper mathematical modeling. So a few words about this as well. So yeah, the mathematical models aim to capture the qualities, let's say, of real-life objects in both static and dynamic phenomena. Dynamic means that we want to understand how a certain mechanism or process evolves in time. Okay, so, and we have a bunch of techniques that we can use for that. So we have linear modeling, nonlinear modeling, and we also have some interesting methodologies that come from machine intelligence and machine learning. And some of those that we've been using are genetic programming and deep learning. Genetic programming in itself is a very, very powerful technique, which has certain properties that make it a little more favorable than deep learning itself, because with the like genetic programming and symbolic regression, for example, we actually get symbolic models, as I will show later. And when it comes to creating intelligent environments, you also need to somehow involve human behavior modeling into the equation. So something like Laban movement analysis could be used for that purpose. Okay, so what are the classical methods of mathematical modeling in terms of dynamics? So we have white box, gray box, black box. And if we overlay the different modeling paradigms together on a single slide, some of those that I have mentioned up until now, you can see that on the left we have the white box model. In the middle we have the gray box, because it involves actually using some computer techniques to estimate the parameters of the models, which we have constructed, let's say, with white box modeling. And then we also have machine learning with genetic programming and symbolic regression and artificial neural networks, which are classical black box models, but they can be also combined in some meaningful ways. So one thing that I wanted also to mention is fractional calculus, since that was actually the topic of my PhD thesis. So if you're aware of regular calculus, then fractional calculus just extends that, allowing the orders of operations to be non-integer. I will not say more about this, but this gives you a lot of flexibility in terms of modeling. And genetic programming, as I mentioned, has high modeling potential, because instead of these, when we use, let's say, deep learning methods in classical sense, what we end up with is just numbers, basically. So we have these matrices with numbers, then we multiply them, add them together, and pass them through some nonlinear functions that are predefined, the classical approach with deep learning or just artificial neural networks. And so what we get is just a bunch of numbers that do not necessarily reveal much about the actual model structure. Whereas with genetic programming and with symbolic regression, we get symbolic models. An example of that is provided on the slide. So you can see that the way that we represent the mathematical equation relating the inputs to the output y can be done in a kind of tree-like structure. And this tree-like structure lends itself very nicely to genetic programming, which allows us to do various operations leading to complex expressions that actually model given phenomena. Very high potential of this, and we will also speak a little more about genetic programming in a short while. So now let's get to some actual real-life examples of how we can implement machine intelligence, or at least create these assistive technologies, or create this these user interfaces that are able to assist or help the user of an immersive environment. So our initial idea with this, since we come from control background, our initial idea was to create a kind of immersive environment for a control lab. So control lab meaning that typically students are given assignments, they need to study this mathematical modeling side of things, and then they're given some real life objects with which they can experiment. They can confirm that, okay, this mathematical model is actually representative of the dynamics of a certain object. Like in the case study below, you'll see that it's a magnetic levitation system, right? So, but we only have a limited number of these objects. And so how do we go from a single object to kind of at scale adoption of all of these techniques? Of course, through the use of digital twins. So this is exactly what we're doing. And we're using MATLAB Simulink for modeling and Unreal Engine 4 to implement the actual digital twins and interactions in the VR. So the concept itself is fairly simple. So we have the visualization engine, which is Unreal Engine, this guy over here. And then we also have the mathematical model, which is running in MATLAB Simulink, which was obtained using the various techniques that I just spoke about. And then we also have the actual thing that makes the immersion possible, which is the HMD. In this case, it's HTC Vive first generation. Now we're usually using something like HTC Vive Pro or HTC Vive Pro I, depending on the situation. And again, I will show you what that means. So these are then, this is the overall schematic of the solution. And if we go forward, then there's a specific use case that I wanted to mention, which has to do with modeling a magnetic levitation system. So I will not go into details of what it is, but basically there's an electromagnet and a sphere, and if you run current through the electromagnet, it will create a magnetic field, and then the sphere will levitate. Okay, so very simple process on one hand. On the other hand, it's also quite involved if you consider the mathematics of it, and especially if you go from this simple lab model to something more interesting like maglev trains, for example. Okay, so mathematical model of that, which was obtained using the techniques described previously. The experiment itself, I will not go into details, but this is what we have in MATLAB, okay? Or rather in Simulink. And here's how it looks if we actually apply it. So we have the lab scale model, which is here. So we started the controller, which is also kind of physical controller, and it's controlling the ball. You can probably see that it's floating in the air, basically. So it's being controlled. And then from that concept, we go into the actual VR implementation. So we can then, using the mathematical model, which is sufficiently accurate to recreate the object and also all of the significant interactions with this object. And then we can also go to augmented reality. So we can take that and put it into a lab space where it is not actually located, but a digital twin of it can be then used in a lab environment like this. This one using Meta 2, unfortunately defunct HMD. Now we would use Microsoft HoloLens for this purpose instead. So that's all well and good, but where's the actual immersive environment, intelligent environment side of it? So let's have a look at some of these examples from the past. So first of all, another example of a digital twin. And here we have a so-called multi-tank system, which has to do with controlling the levels of fluid in these 3 tanks. So as you can see on the right here, we have the real system, and on the left we have the digital twin. And these spheres, which you can see right now, are used to tune a controller, which is used to, let's say, keep the levels in the tanks at the desired levels, or at the desired set points. So, okay, this has to do more with digital twin approach, but you can see how it can be applied. So we have the real system, we have the digital twin side by side in the last few frames there. What we can also do is, let's say, using Microsoft HoloLens, we can also overlay that object into the real world, which could be used for, let's say, remote monitoring or something along those lines, because you can also interact with this object. Okay, so with the spheres, the idea of tuning comes into mind, and automatic tuning is one significant aspect of control systems if you take a look at the industrial landscape. So by the way, this work was also awarded with first prize state competition and research studies by my student. So now we go to automatic tuning idea, and for this one, the example is with Logitech VR Ink, which is a VR pen. And in here, what we do is, again, we are inserting in virtual reality a mathematical model of a process, very simple one, well, fairly simple one. Still has to do with fractional calculus, since we have the transfer function order to be non-integer. And now what you do is let's say you draw the desired response, the time domain response of your system, and then what happens is this is transported into an environment which can compute it, and then it computes the parameters of the controller. So instead of resizing the spheres, right, it is done automatically. So you can see the results immediately, and you can use this approach already as a kind of stepping stone towards this intelligence, because you have just been assisted by a program that was specifically designed for the purpose of automatically tuning a controller for your system. Maybe that's a lot to take in, but just bear with me a little longer. Right, and so here is an example of specifically an intelligence aspect of a control system. So here we are using a different object. We're using a 3D crane, which is a lab scale model of a gantry crane. The idea is that we can change the desired location of the load, which you can see right now is swinging. And we can also change the control mode so that the swings would be minimized. If we were to automatically control a gantry crane, swing is not allowed there at all, so we have to take this into account. Okay, so this is a kind of experiment that we give our students to do. But then how do you know when the load is swinging and how the system in general works? So in virtual reality, you can also use widgets. And this is what's going on here. So you see there are widgets. That one of them shows the time series of the signal, so the performance. The other one shows you the physical model. Okay, so you can place them in the world around you so that you can create a, let's say, working environment how you want it. So you can think about it as just moving your monitor to the left or right. But then you can also throw these. Throwing mechanic is very interesting in VR. A lot of people love to throw stuff around in VR. So in here we decided, okay, we throw the widget, and then it appears on the window to the right at the moment. See there, and And as in doing so, it's a kind of natural mechanic. But sometimes these throws fail. One of the throws previously actually failed. So this is where what we can do is to try to predict the user's action and assist the user in doing so. And for that, what we did is we created a kind of replay system and a labeling system. And looking at this one, so this is a recording that you can see here of a user in a virtual reality space. And it's very interesting. The next topic that we will have very little time to discuss, but we'll try to breeze through it. It's very important, but very, very difficult to discuss in very limited time. So anyway, you can see the head of the avatar basically, and the controllers. And it's very interesting that the brain, what the brain does in that sense, that when you see it moving, it kind of reconstructs the whole body. Very interesting effect. When I saw it for the first time, I could not believe my eyes, but just try and look at it, right? So you can see the brain can reconstruct the body. It's not there, but you can see it. Okay, very, very interesting effects. In this case, there's also eye tracking enabled, and we know what the user is looking at and so forth. So we can derive a lot of information from this stuff. So the replay system actually was also awarded with a project that is running, a European Erasmus Plus project, as one of the best contributions in there. So that's quite nice. But okay, so we have seen some examples of how we can endow the environment, in this case related more to control systems, but you can think about any other application as well, and how your environment can be endowed with this intelligence. So let's speak very briefly about this idea of conscious agents. It's a super interesting topic because what we want to generalize, we want to take the initial ideas, the specific implementation is great, fine. But then we have to generalize. We are researchers, well, at least here at Taltech, we want to generalize it and we want to move forward with a very strong framework. So conscious agent seems to be such a framework because it combines all of these aspects together in some sort of coherent way. Okay, so AI can be considered advanced automation at this point, at least from the implementation perspective. So it's not actually true intelligence, right? So how do we move from AI just as it is to true intelligence? The idea, or how I found this research, was actually quite interesting. I thought about it as a consciousness mirror. So whenever you're thinking about artificial intelligence doing something on its own, it doesn't do it, but it does it only through us. Right? So we are the consciousness, and then we endow AI with consciousness through the way of implementing it, through developing it, and so forth. This is a kind of consciousness mirror. And turns out that there's a whole framework developed about this, which is Conscious Agents by Professor Hoffman and Prakash. For example, Objects of Consciousness paper describes this. So the idea is, of course, not only consciousness itself, but also the relationship between evolution and perception. Perception meaning how we interact with everything in the world, because we do it only through perception, right? And the theory goes that the evolution has shaped our brains, or let's say has shaped our perception not to see the true nature of the world, but to satisfy some fitness functions. Fitness means if you're fit, then you're good to go and survive and reproduce, right? If you're not fit, sorry, you die out eventually. This is evolution in its main idea. Okay, so the key point here is that evolution has shaped perception not to see the truth, but rather see something that caters to the fitness values and to improve the fitness. Right. So the interface theory of perception is one really interesting aspect of this. What it means, in fact, is that, okay, here you see the old man taking the computer icon to the trash can, and then the physical computer disappears from existence, which does not happen, right? Or rather, the monitor disappears, at least. So this does not happen. This is a kind of abstraction. This is the interface, right? And if this is the way that we can think about perception, right? Then it's easy to generalize it also to other aspects of perception. Right, so perception, decision, actions is what makes a conscious agent definition. Some more boring mathematics and a diagram of a conscious agent. So we have the world, we have the experience, we have the action, and then the complete cycle goes through perceiving, deciding, and acting, which is closed cycle, okay? And here's an example of two conscious agents. I will not spend too much time here because the idea of these conscious agents is that we move from the interface theory of perception to conscious agents, which make up this whole idea of the interface. And so, which makes the interface possible in the first place. This is how this is connected. Right, so there are two hypotheses which I find really interesting. First is conscious realism, that the world consists entirely of conscious agents. And the second one is that, which is called conscious agent thesis, every property of consciousness can be represented by some property of a dynamical system of conscious agents. And this again brings us back to the modeling aspects of it. If you remember, we spoke a little bit about dynamics there. So all of this somehow comes together. So what are the implications for intelligent immersive virtual environments? Well, there are several things that we can discuss here. So for instance, immersion stems from the CA perception of the virtual world, W prime. And so in this case, conscious agents refers to actually a collection of conscious agents. For instance, we can see a human as a conscious agent, but we also know that our body is composed of different kinds of cells, which are also interacting with each other, and so forth and so forth. So it's kind of combination of these conscious agents, right? So, and then this immersion stems from the perception of the virtual world. Any intelligent element of a virtual environment is a reflection of the conscious agent in that world, including the meaningful interactions with digital twins and others, maybe subjects. So, and this intelligence is a kind of concept that comes from the experience of a combination of CAs. And so if we think about developing the virtual world or the virtual environment, let's say, with those ideas in mind, I think we will create a very interesting model that we will be able to bring forward and then use as a kind of part or the foundation for implementing these intelligent immersive virtual environments. Right, so again, in this talk, we brought together several ideas, including digital twins, mathematical modeling, machine intelligence, and then we've also introduced the concept of conscious agents very briefly, unfortunately, but this is due to some delay in the talk at the beginning. So doesn't matter, you can check out the paper. It's a very interesting paper. It does involve a lot of mathematics by the end, but it's not deterring from understanding the concepts that you can learn from there. So highly encourage you to read it. So some acknowledgements. There first is the platform which has been recently rebranded as XR Bootcamp. But we are really grateful to them for their support over the years. And also, if you're new but interested in XR, in this case, I highly recommend you checking out the project that I mentioned previously in passing, which is VAM Realities, found at vam-realities.eu. So, and especially if you represent an SME or HEI, small or medium enterprise or higher education institution, we have some really nice materials that you can explore. And like, just to conclude, what I always consider the ultimate XR experience, more kind of VR experience or virtual environment experience, is basically a lucid dream, which is in fact something that is directly related to the idea of a consciousness mirror. So thank you very much for your attention.
Dear Alexei, thank you very much for the webinar. And I am checking the YouTube first. Question from there. And I'm also checking the Zoom session. Just to say that I may miss some part about the control part. For example, you show a line, and you show you can change the line of the control. You know that I forgot that figure, but well, what is the application? What is the use of virtual reality in that stuff, in that control? Could you remember that there is a line and you change the line of line to make a
Yes.
smooth control, and I may miss that part.
Yeah, this is a very good question, actually. The thing is that the implementation, you're probably referring to the fact that there was a virtual pen and then you could draw the desired response, right?
Mm-hmm. Yeah,
so, and then the system would automatically pick that up and optimize the controller according to that specification in the time domain.
Mm-hmm.
Yeah.
You totally reduce the overshoot, as I see.
Say again?
You remove all the overshoot. You know, there's an overshoot, and you remove the overshoot and make a smooth control. Mm-hmm.
Yeah. So you can it depends on the specification, actually. Sometimes we want the overshoot to be there, but the control to be, let's say, more responsive, so it's a long story, actually, but I think I can briefly comment on this question also. That yeah, you can draw any response you like, and if it's possible for the system to obtain that response with a fractional PID controller, it will optimize it and will give you the result. One thing that is missing there right now is the frequency domain specifications, because this is how you specify robustness, let's say, so that the system remains stable during operation, even if there are disturbances and things like this. So this is currently missing, but I think the better question is, okay, what do you gain from the fact that you do it in XR specifically, right? Because this application was developed as a kind of, it can be used with a flat screen easily. In the same way, you can take a pen, like a digital pen like this, and you can use a touch screen and you can draw the response, and then it will do the same things. However, in extended reality, what you can do, you can also endow the virtual environment with these digital twins that we have been discussing throughout the talk. So that means that everything will be in one place. And this is, I think, going to be very important for educational purposes, because you can place a digital twin, let's say, of this 3D crane or multi-tank or whatever you have, it doesn't matter. And then you can do the same procedure with this interactive whiteboard, and then you can see directly on the object of interest how this control will play out. I think that is quite important.
Yeah, okay, like the middleware, you can consider the middleware. For example, it seems like the ROS, robot operating system, for example, for the when you use a robot operating system, in fact, you can model, you can use the same model, okay, the model of this exact robot, real robots. For example, instead of paying a few hundreds of dollars, for example, $900 US for a robot, you can choose so many robots, and you can make an experiment. And in fact, people consider it as not hardware, because you can still use some kind of soft tissues, but you can make some experiment, and more realistic experiment, and people call that as implementation. So digital twin or virtual reality gives you this opportunity to in the robotics, as I remember. What do you think about that? You also talk about some robotic applications, and there are also some other platforms as I remember, Webots or some other platforms. For example, the ROS was also integrated with the MATLAB. There is such a tools. In fact, yeah, the increasing the techniques, the virtual reality, and also the other techniques help us very much, and it makes some issues cheaper and cheaper, and makes our experiment in fact freely, instead of paying thousands of dollars. So it has really interesting applications. And Ali say, what kind of material available in one for HEI? Okay.
Yeah,
Ali,
so
it's a good question.
I guess the question was about VAM realities. So we have several different things there, and one of which is state-of-the-art report on extended reality technologies. This can be probably used by everyone, SMEs, HEIs. There's a very gentle introduction to the technologies and to what they offer, and also review of recent hardware, software, and use cases. There's also a study of SMEs. So if you want to establish, let's say, university business collaboration in this field, then maybe you want to check that out. It let's say, outlines the issues, let's say, an adoption of XR technologies in SMEs. I think primarily it was SMEs, not HEIs, but for HEIs looking for collaboration in that space, I think it's important. Then there's also guidebook on extended reality technologies, handbook, sorry. So that's primarily, I think, targeting SMEs, but could be also used. And of course, there's also the network itself. So if you go to VAM Realities, there's a network of experts and also users of extended reality. And if you want to expand your network in terms of HEI, let's say, then you might want to check that out as well. So once again, the website is vam-realities.eu. So you can find all of those materials there, and you're welcome to like forward me any other questions later about the project and the deliverables and whatnot.
Thank you very much for your answer.
Thank you for your question.
Other questions, if any? Thank you very much for this great session. It is a really interesting session, I think. I hope the attendees also enjoy this session and rewatch this session. And I think it really provides some interesting results and also intuitions and directions for people. And thank you very much for your time. Do you want to say any final word about this topic, this webinar?
Well, yes. First of all, there's an upcoming webinar, which I think the topic is quite close. It's also related to digital twins, and it's also going to be hosted with Young Professionals R8. So I welcome anyone watching this one to attend that as well. And I think that extended reality technology has come a long way, and with Facebook doing this move to Meta, to become Meta, and other phenomena that are currently occurring, I think it's safe to say that if you invest time and effort into this technology, it will definitely pay off, and you will be on the front of technology for years to come. So thank you very much for attending.
Thank you very much for this great webinar, and it is our pleasure to host you as a speaker in our Community Expert webinar series. And to make this webinar with IEEE Young Professionals Estonia is also another pleasing collaboration for us. And thank you very much for joining our session, dear attendees. And we are waiting you for the next webinar nearly 1 week later. On November 12th. Thank you very much for participating in this session.
Thank you. Bye.